So before we leave Houdini and go back to Cinema 4D, there's a handful of things that I want to discuss and maybe a couple of adjustments that I want to make that are just going to make life in Cinema 4D a little bit easier and nicer for us. And the first thing I want to talk about is just how do we output this thing at all? Like, how do we get this out of here? And there's a handful of ways that we can do it, but we're going to use the ROP Alembic output. That's this guy right here. So we're just going to plug this in after our out node. And, you know, if we had animation, we could set an animated frame range. This is going to allow us to, you know, tell it where it's going to go. But one of the most important things, at least to me, is this build hierarchy from attribute. And we want to check this on. And right now what it's looking for is this attribute called path. And basically what this is going to do is say any polygon that has the same path attribute as another polygon, those things are going to be together in the same hierarchy item in Cinema 4D when we bring it in. So if we were to output this all right now, we would just get one object in Cinema 4D in the object manager. And that's fine, sort of, but it would be way easier if all of these components were separated so that we could texture them separately or treat them separately, turn them off and on, that kind of thing. So that's what we're going to do. We're going to set up this path attribute. And to do that, what I'm going to do is I'm just going to start over here on this side. And I'm going to drop in an attribute wrangle. And it's just a string path attribute. It's nothing too crazy. We want it to run over primitives. We want to set this up as path is equal to, and in this case, let's call it internals. And we want to put that in quotation marks because it's a string. But strings always get quotation marks around it, and we'll throw a little semicolon at the end. Okay, cool. Let's go ahead and duplicate this, and we'll bring this down over here to this. And let's call this extruded polys, just like that. And I don't want to use any spaces. Houdini doesn't tend to like spaces very much. And even though this is a string and spaces are probably fine, well, be extruded. I like using underscores anyway. It just keeps things clean and prevents any errors from being introduced. So let's go ahead and duplicate this over here. This one's going to be called cubby holes. And we're going to duplicate this again. We're going to bring it over here. This one's going to be flying polys. This one's going to be flying polylines. And duplicate this again. This one's going to be up here. We're just going to call this one polys 1. And this one will be polys 2. And that should give us everything. Now, we do also want to come down here and make sure that we keep that attribute, because remember we have an attribute delete SOP in here that is currently deleting all of our attributes. That's not really going to work so well. So we need to go in here and also tell this. So we can say we want to keep the path attribute. So down here, and make sure I have my path attribute still there. That's great. Cool. And we can see that if we go over here, path attribute, extrude poly. So like all the extruded polygons are going to be in one object in the object manager in Cinema 4D. And we'll see that once we get this all exported and brought into Cinema, we can check that out. The next thing I want to do is make sure that I have some groups for some polygons that I can work with in Cinema 4D. So any groups that we have, point groups, polygon groups, whatever, here in Houdini, those will actually translate to Cinema 4D as groups as well. So any groups you have set up here, they will be brought in into Cinema 4D. So what I want to do is I want to go up here to my poly extrudes, and I just want to output groups for the front and for the sides. It's just a good idea to have those. I'm going to jump into my subnets and do the same thing in here. So select my poly extrude, go back here, tell it to output front and side groups. I'm going to do the same thing over here. Oops. That doesn't have the poly extrude, that's down here. So this poly extrude also gets front and side groups. Okay, cool. I'm good with that. So all those extruded surfaces are also going to have groups so that we can do different materials even on the front faces versus the side faces. So that's pretty cool. And these polygons here are actually kind of boring. I think we can take our little subnet guy here and bring this up. And we'll select this, we'll bring this in here and let this do its thing. And I'm gonna come in here and we're just gonna bypass this poly extrude. We're gonna let this one out here do the business for us. Let's see. Yeah, this is extruding them all at the same distance. That's not so cool. We're gonna jump in here. We're gonna delete that one. We are gonna use this poly extrude. We're not gonna extrude that far. Let's do like 0.1. That way we don't have like so many extreme extruded polys. We have some that are a little closer to the surface. Because that'll just make things look interesting. We don't have so many just straight up squares. And again, we're outputting groups here, so that's good news. Okay. Great. And jump to the end, make sure everything looks okay. That looks just fine. Digging that. The next thing I want to do is actually add some bevels to some of these polygon surfaces. Now that's something that we could, in theory, do in Cinema 4D, but there's a handful of advantages to doing it here in Houdini, not least of which is that it's a little faster. But we also can get groups for the bevels themselves so that we can even texture the bevels as a separate component. So I'm going to go up here. We're going to start up here on these. So we'll zoom right in here. Right now there's no bevels on them at all. So I'm just going to drop in poly bevel. And we'll just throw this right in here in line. And it will take a second to calculate. And let's give it a distance of like 0.01. Let's see what that does. We'll start there. These are pretty small shapes. It does take a second. Okay, so we can see it did something. It seemed to have like added a bunch of lines along this edge, which is weird, and it kind of looks a little gross. So let's make some adjustments and fix that. So the first thing I want to do is tell it to ignore flat edges. So that means it won't bevel all of these edges. It's only going to bevel the edges that are around a corner. So we'll tell it to not do that. That looks a little better. Still looks kind of gross though. So I think the bevel is probably way too big. So we'll fix that in a second, but I do want to change the shape to a solid. And I'm going to, oops. Let's take our divisions down to 1. And I'm going to add, I'm going to make this much smaller. We'll do 0.001. There we go. That looks a lot better. That's a nicer looking bevel. The geometry looks a little gross, and that's because it's kind of screwing up our normals. But if we throw in a normal SOP down here and reduce our angle, you can see our geometry is actually okay. It's totally fine. So that actually gets resolved down at the end. So I'm not so worried about the geometry looking a little funky. I'm okay with that. What I do want to do is tell it to output edge and corner faces as a group. So bevel prims will be my group for all of my beveled edges. So I can even texture those separately. Great. Let's go ahead and just copy and paste this We'll bring it down here to this set of polys and just apply the same thing. Should be okay. Yep, I don't see anything. Now, every now and then, if you have particularly small faces or something, you might end up getting polygons that kind of bevel off into infinity. And so it's good to just kind of back your camera up and check and make sure you don't have like a face that's like shooting off into the middle of nowhere. Let's go ahead and do the same thing on our flying polys. So we'll just plug this in over here. Same thing. Yep, those look nicely beveled. That way we'll get some nice edge highlights when we light this thing in Cinema 4D. One of the other things I would like to have in Cinema 4D is the ability to randomly assign materials to an object's polygons. So for that, I'm going to make a group on each of my major polygon streams here. So we'll start with this stream. I'm going to make a group that basically randomly includes some of these polygons. And we're going to do that. We want to do that before we even get into extruding all of these surfaces. So we're actually going to do it in here in my subnet tool. I'm going to jump in here before our poly extrude, but after our normal. What I'm going to do is throw in an attribute wrangle, and we're going to set this to primitives, and we're going to make a group here in the primitive wrangle. So what we're going to do is write an if statement, and an if statement has two primary components. So it starts with if, and then we have an open and close parentheses, and an open curly bracket, and a closing curly bracket. So basically, if I were to write this out as I would say it, it would be, if this is true, then do this. So that's basically what the structure of an if statement is. So in this case, the thing we want to be true, we're just going to give the polygons a random number, and we're going to say if the random number is greater than 0.5, then put it in the group. So we'll say if rand, and remember the random function needs a random seed, and we're just going to use the primitive number at primnum. If that number is greater than 0.5, then the thing to do would be to join a group. The way that we write out a group in Vex is this. We say at group underscore, and then whatever the name after the underscore is what the group is going to be called. So in this case, we'll just call it random polys. And then we just set that value equal to 1. So that means that if the random number based on the primitive number that we've got in here is greater than 0.5, which basically means, in theory, half the polygons are going to be in this group, then we're going to put that polygon into the random poly group that we just created. So we'll see if I middle click here, we now have a primitive group called random polys, and it has 232 polys in it, and we have 439 polys total. So that's about half. Cool. That's great. So I'm actually just I'm gonna copy this because I'm gonna reuse it, and we're gonna come back here and make sure that we turn on our poly extrude again. We're gonna do the same thing over here in this subnet. We're just gonna paste this thing right above our poly extrude. There we go. So again, same thing. If I middle click up here, random polys 313, total of 606 polygons. So about half. Great. And I'm just going to do the same thing for the flying polys as well. And their poly extrude is out here. So I want to make sure that I made it angry somehow. There it is. I don't know why I pasted down there, whatever. We want to make sure that this ends up here. Cool. And again, we have random polys 162, total 320. So a little over half, but you know, half-ish. So that's just going to give me a group on each of these things that I can assign like a slightly different material to. And you can have as many of those groups in there as you want. It doesn't really matter. The only limit is memory, really. So each of those groups does take up a very small amount of memory, and for the number of polygons we have in this thing, it doesn't really matter. You know, if you had hundreds of millions of polygons, that might make a dent. But for what we're doing, not a big deal. And the very last thing that we're going to do before we export all this stuff and get into Cinema is we are going to assign a random color attribute to our polygons, because when we output this, we aren't just able to transfer groups, we're actually able to transfer other attributes as well via things like vertex maps. So we'll go into our subnet here for this group of polys. So what we're going to do is create a attribute. We're just going to say, we're going to create a float attribute, f at rand color is equal to rand at primnum. And we're going to do it that way just so we can have a little bit more control over the color. Now, the thing that I want to watch out for is that I'm also using rand prim number up here. So I kind of want to modify my random seed for this particular random value, and that way I don't end up with things that somehow might align in their randomness, if that makes sense. I want to use a different random seed, so I'm just going to multiply this times some random decimal number. I'm just going to make up some garbage. And that just modifies that random seed so that these two functions don't ever align. I don't think it would actually cause any problems if they did, but you never know. Let's just be safe. Then I'm going to throw in a color sop after this. And we're going to say this is primitive color. And we're going to do ramp from attribute. And rand color is going to be my attribute that I'm going to use. All right, great. So you can see I have a bunch of random colors assigned to these things. Awesome. So I'm just going to go ahead and copy these two nodes. And I know that I already copied that attribute wrangle, but we're just going to do it again. Why not? Not going to hurt anything. I'm going to go in here into this subnet. I'm going to delete this. Paste these two in here. There we go. So same exact thing. And let's do the same thing for our flying polys as well. So we're going to go up here. This one, I'm just going to delete this out. Paste these in. Wait for Houdini to think for a second. And pop them right in there. There we go. Out flying polys with some random color. Great. All right, I think it's finally time to export this stuff. So let's go back down to the very bottom down here, and let's click on this. Let's take our normal cusp angle. Let's take that down to like 20. 60 looks sort of gross and weird. 20 looks nice and sharp. Everything looks fantastic. The other thing that we want to do, because scale is so whacked out when you get it into Cinema 4D, I'm just going to throw in a transform, and we're just going to do the, we're just going to multiply it times 100 here. So it's going to be gigantic, but that's okay, because in Cinema it won't be. All right, so the very last thing I want to do is just go through and make sure that all of my attributes are set up to export correctly. So we have normals going out. In my attribute delete, I am not deleting my CD attribute. I'm not deleting my path attribute, so that should mean that my ROP Alembic output will be happy. But I do have this primitive attribute CD that I need to get onto the points. That was the attribute that we built for all the random colors of all our polygons. So let's go ahead and do a an attribute promote up here above our attribute delete. And we are going to promote from the primitives to the points our CD attribute. Cool. So this is what that looks like. So that CD attribute on the points will come into Cinema 4D as a vertex map. And generally speaking, any attribute that you have that you want access to in Cinema 4D should be on the points. So let's, just for the sake of demonstration, I'm going to make a random attribute on the points, a random float attribute, and we'll see that come in Cinema 4D as well. So we're going to throw in an attribute wrangle. I'm just going to throw it in down here, and we're just going to call this f at random var, sure. And we'll just call, we'll just set this to be rand at ptnum. Okay, so we just made a random float attribute. We'll see that come in Cinema 4D as well. We're not going to use it, but it's, just to demonstrate the purpose of this. So we'll be able to get color, which is a vector attribute. We'll be able to get this random var float attribute. And so I think we're almost all set up here. So I've got my output path all set. I've got build hierarchy from attribute all set up here. And I've got the path attribute feeding all the way down here. So I think we're good to go up here and hit save to disk.